Hey there, welcome to our channel. In this video post we'll discuss the working of vSphere CPU Scheduler in default, SCA v1 and SCA v2 modes in 6.7 Update 2 and later. VMware vSphere 6.7 U2 features a new scheduler option called as SCA v2, which provides security for L1TF vulnerability, while retaining as much performance as possible. However, before we dive into CPU scheduler modes and details, it'll be helpful to go through basics of CPU scheduler quickly. Modern processors are equipped with multiple cores per processor. Furthermore, it is possible that you may have multiple sockets in the system that adds up more to the processing capacity. In such large systems, allocating CPU resources efficiently and fairly is a critical process. What is CPU scheduler? The role of the CPU scheduler is to assign execution contexts to physical processors to ensure objectives such as responsiveness, throughput, and usage. On conventional operating systems such as Windows OS, the execution context is represented by a process, but on an ESX host, the execution context corresponds to a world. A VM running on an ESX host is a collection of worlds such as one world per virtual CPU, one world for SVGA device, one world for keyboard, mouse and screen. There are non-virtual machine worlds as well which exist in an ESX host. These non-virtual machine worlds are referred as VM kernel worlds. VM kernel worlds, such as vMotion Server World, are used to perform system tasks on an ESX host. Example, VM App 01A, there are multiple worlds listed in ESX host. As you see here in this image, these are worlds for VM App 01A with GID 43223. CPU scheduler is responsible for choosing which world is scheduled to a processor, LCPU. CPU scheduler uses algorithms such as proportional share-based algorithm, and relaxed co-scheduling for scheduling. Relaxed co-scheduling is used for multi-CPU, i.e. 2 or more virtual CPU, VMs. These multi-CPU VMs are also known as SMP or symmetric multiprocessing VMs. Every 2 to 30 milliseconds, CPU scheduler checks physical CPU usage and migrates virtual CPUs from one core to another or one socket to another if necessary. Default time slice is of 50 milliseconds, which means CPU scheduler allows of CPU to run on LCPU for max 50 ms. CPU scheduler is fully aware of NUMA architecture. Hence NUMA, wide NUMA and virtual NUMA are taken into consideration while scheduling. CPU scheduler modes. In August of 2018, a security vulnerability known as L1TF, concurrent context attack vector, affected systems using Intel processors. Intel provided microcode updates for its processors, operating system patches were made available. VMware also provided an update in Security Advisory VMSA 2018-0020 known as Side Channel Aware Scheduler, SCA v1. In vSphere 6.7 U2, the Side Channel Aware Scheduler has been enhanced with a new policy known as Side Channel Aware Scheduler, SCA v2. So now, CPU Scheduler in vSphere 6.7 U2 and later can be configured in either of these three modes. Default Scheduler. SCA v1. SCA v2. Default Scheduler Mode. In this mode, multiple virtual CPUs of VM are scheduled across the physical cores. As we all know, one physical core can handle 32 virtual CPUs, however, this is true for virtual CPUs of different VMs in this mode. Note, multiple virtual CPUs of a VM are not scheduled on same physical core. So the virtual CPU mapping would look something similar as in screenshot. As you can see in image, different VMs are sharing the physical CPU simultaneously, which raises security concern. A VM running on one thread of a core can observe information used by the other thread of another VM on that core. Default scheduler mode uses host security boundary model. This model is designed to prevent information leakage between hosts. However, this model allows information leakage between VMs running on a given host. VMs running on the host are considered to be part of the same information security boundary. This model security boundary can be illustrated as an image. Using L1TF concurrent context attack vector vulnerability, a VM on the host can access any information on that ESX host. All credentials, crypto keys, and secrets used by the hypervisor or other VMs on the host could be obtained by a malicious guest. SCA v1 mode. Side Channel Aware Scheduler or SCA v1 mode can be enabled through the advanced settings as This mode uses process security boundary, which ensures information is not exposed across different processes within a guest itself. This mode provides the highest security, however it also has the lowest performance of all possible modes since not all hyperthreads are used in this mode. How does this impact scheduling? Let's assume a scenarios here of two VMs, VM1 and VM2, each with 4 virtual CPUs, running on an ESX host with single quad-core CPU with hyperthreading enabled. Now say, we powered on both the VMs on the SE. One of the VM will get scheduled first, and after time slicing, other VM will start execution. If you notice, from each core only one thread, HD0, is used. Another thread, HD1, is idle. HD1 thread is not used even if second VM has demand and waiting for getting scheduled. So once the first VM time slice occurs, second VM will get scheduled as shown. HD1 thread is in idle state again. With this model, two worlds of the same VM has no access to each other's information. One thread is always idle, which results in reduced performance. SCA v2 mode. SCA v2 mode can be enabled by setting below advanced options. SCA v2 uses VM security boundary, in which VM is treated as security boundary. The image illustrates VM as security boundary. This mode provides a balance of performance and security for environments where the VM is considered the information security boundary. Unlike SCA v1 mode, SCA v2 mode uses both the threads of CPU. Also, unlike default scheduler mode, SCA v2 allows usage of both CPU threads by the worlds of same VM. So if you take previous example again, where we have two VMs as VM1 and VM2, each with 4 virtual CPUs each, may get scheduled as an image. As you can see, both the threads are being used. However, it is ensured that both threads are used by same VM. CPU threads are not shared between VMs due to VM security boundary model. Wrapping up, vSphere 6.7 U2 and later will use the default scheduler unless configured to use one of the other options. In order to use SCA v1 or SCA v2, a couple of advanced options must be set and the host rebooted for changes to take effect. The security vulnerabilities with L1TF can now be mitigated safely with the new SCA v2 option available in vSphere 6.7 U2 and later instead of SCA v1, which has performance trade-off. SCA v2 allows the hyperthreads to be used only by scheduling VPS from the same VM on the same core, and this regains some of the performance lost due to mitigations made necessary initially. These are the required advanced option settings for each of these modes. You can use SCA as well to set these options as shown here. Thank you for watching. Please do like and subscribe for more informative videos like this.